Hey guys, in this video the lovely Mr. B is going to be doing trigonometry for your A-level maths. Now this is going to seem familiar because we've done it before at GCSE, but we are taking it to the next level. So lots of examples here worked through really slowly. If you want more practice questions to go with this, then there are loads more waiting for you over my website.
We are going to revise GCSE trigonometry, which is also really important at A level. So the first thing we'll do is look at Pythagoras Theorem, then we'll look at SOHCAHTOA, Sine Rule, Cosine Rule, and area of triangles that don't have a right angle. So first let's have a look at Pythagoras Theorem. So you should remember that a squared plus b squared is equal to c squared. Now a and b can be either of the short sides. So I could do that the other way around if I wanted to. C is always the hypotenuse, the longest side. And on this diagram, it's labelled for us, but if it's not labelled, it's always opposite the right angle. So all we need to do is substitute to start off. So A is going to be 93.3 squared. B is going to give us 75.5 squared. And it's all equal to c squared. In a calculator with this, we can square these numbers. So for the 93.3 squared, we're going to get 8,704.89. For the 75.5 squared, you should get 5,700.25, and the answer to that is going to be equal to c squared. So now we're going to add them together. And thinking about it, I don't really want to write all those numbers down again. So is there a way to do this a little bit more quickly? And what you might want to do is to just type both squared bits into your calculator. So type in 93.3, the squared symbol, press the add symbol, press 75.5, and then that squared symbol, and it's going to give you the combined total altogether. Now, the really important thing is that this number is not the answer. The answer is not 14,000. That's equal to c squared, and the length of the side we're looking for is c. So now we have to kind of think about our solving equation skills, and we are going to square root both sides. So if we square root both sides, we're going to get 120.02 to two decimal places on the left-hand side, and on the right-hand side, c squared is equal to c, because the square and the root cancel out. So we've got the length of the third side. At the end, you might just want to write out the number again and make sure that you include the units. So that is our final answer to two decimal places. If you want to speed this up a little bit more, we can rearrange Pythagoras Theorem so that c is equal to the square root of a squared plus b squared. And the benefit of this is we can type the entire thing onto our calculator all at once. So you might just want to try pressing the root symbol. I would open some brackets for the bit inside the root symbol so the calculator knows exactly what's been rooted. Then type in the a squared number plus the b squared number. Make sure you close your brackets, that'll be really important, and you'll get the answer in one step. We'll have a look at one more example. So again, it's Pythagoras Theorem. A squared plus b squared is equal to c squared. So we can label the diagram. A is labelled for us already. A and B are the two short sides. C has to be the longest side. So the 300 side has to be C. It's opposite the right angle, it's the longest side. Now, there's a little difference here that we don't know what A is, so we can't do A squared. We know what B squared is, it's going to be 259.8 squared, and we actually know what C squared is, it's going to be 300 squared. So this one looks a little bit different, so you're going to have to rearrange. Now what we can do is we can take the 200 number away from both sides, and that'll give us A squared is equal to 300 squared take away 259.8 squared. So by rearranging, making A the subject, this is now going to be a takeaway question, not an add question like the previous one. Now we can take 300 squared, we can take away 259.8 squared, and that's going to give us, for a squared, 22,503.96. So again, think about your solving equation skills. If we root both sides, we're going to get what a is equal to. Because we're not looking for a squared, we're looking for a. And so the square root of that number should give you 150.01 to two decimal places. And for your final answer, make sure you're writing the units. It was in centimetres. Now, if you go back and look at the formula, a squared plus b squared is equal to c squared. Again, there is a way to do this all in one step. And so you think about it, we rearranged it so that a squared is equal to c squared minus b squared, and then we had to take the square root. So you can say that a is equal to the square root of c squared minus b squared. Again, you type it into your calculator and put some brackets again around the inside of the root symbol. That will get you the answer in one step. And the benefit of that is when you get to some of the longer questions, which bring in multiple topics together, you can't really fit all the detailed working out on the page. So you just want to get a quick answer so you can move on to the next part of the question. If you do this though, do write down the formula so the examiner knows what you are attempting to do. And they can see, oh yeah, they're trying to use Pythagoras Theorem, just in case you make a mistake and you want some method marks. The next part of trigonometry is SOHCAHTOA. So if you write down this acronym, what it does is it just reminds you of the steps to take to solve these questions. The first thing to do is to think about what all the letters mean and then refer to the names of the sides of the triangle. So the longest side of the triangle that we kind of labeled C in Pythagoras Theorem, we call that the hypotenuse. It's the longest side, it's opposite the right angle. Then we've got the adjacent. Now, the adjacent is a line that's next to both angles. So you can see the line I'm highlighting, it touches both of the labelled angles in the triangle. Now, triangles do have three angles, but the third angle that it doesn't touch, it's not labelled, so we don't care about it. The last side is the opposite. Now, just like the hypotenuse is opposite the right angle, the opposite is opposite the other labelled angle. So to the other side of the shape. A good way to think about opposite is that no part of the opposite line touches the angle it's opposite. So no part of that line with the O next to it actually touches angle B. Whereas the adjacent will touch both of the angles. Now, once you've labelled this, you need to think about which ones are important. Now, the important ones are the ones that are labelled. The H is labelled and the A is labelled, but the O isn't labelled. We're not looking for it. We don't have a value for it. So we don't care about O. So we look at SOHCAHTOA. We think which one has got A and H in it. And it's the middle one. Car has got A and H in it. The other ones will have one or the other, but they don't have both. So now what we do is we can draw a formula triangle for car. Now you don't need to remember how to put it into the triangle because it's just in the same order it's in the word. Car, C-A-H. So you write C, A, and H in that order. Now, the reason why it's a triangle is that if the two things are next to each other, they're going to be multiplied. If they're on top of each other, they're going to be divided. So you can see there's three possible calculations. We could do A divided by C, A divided by H, or C multiplied by H. So which one are we going to use? Now, it's all about the thing that we're looking for, and we are looking for the angle. So we've got A, we've got a value for it. We've got H, we've got a value for that. We're looking for the angle. And so that's represented by the kind of trigonometry word, in this case, C. But when you use SOHCAH or TOA, that's standing for sin, cos, or tan with the first letter. That first letter is always about the angle. So what you do is you cover up the thing you're looking for. We're looking for the angle, cover it up, and you see what's left over. And we can see we've got A over H in the triangle. So that's the maths we're going to do. So the way we write it is the cos, and it's always cos of the angle. So this is going to be cos of B, the angle we're looking for. It's equal to A divided by H. And so we can substitute into this. So A is 128.3, H is 160, and so we can do that division, which means that cos of the angle B is equal to 128.3 divided by 160, which gives us 0.80175. Now that looks very odd for an angle, and we haven't actually found the angle B. We've found the cos of B. So what we can do now is we can use that kind of solving equation skills, and we think, well, if we did the opposite of cos to both sides, we'd have B on its own. And that's actually what we're going to do. We're going to do the opposite of cos to both sides. Now, you'll see this written as cos minus 1 on a calculator. Sometimes it's called cos. Do cos of minus 1 to both sides. Cos and the inverse of cos cancel out, just like plus and take away cancel out, or multiply and divide cancel out. On the previous questions, squares and roots cancel out. But then we've got to do the cos minus 1 on the other side. So on your calculator, cos minus 1 is usually above cos. You might have to press the shift button first and then press cos, and then it'll give you an answer. And it gives me 36.69 degrees to 2 decimal places. So to recap the steps, you label the triangle, you decide if you're using SOHCAH or TOA depending on which sides are labelled, and you draw the form of the triangle. Then you write out the equation the form of the triangle gives you, and you substitute into it, and you rearrange whatever you need to solve it for what you're looking for. In this case, the missing angle B. So moving on to the next example, first label the triangle. The longest side, the hypotenuse, is H. If it's not clear which side is the longest, it's opposite the right angle. No part of that line touches the right angle. The opposite is the line that's opposite the other labelled angle. In the adjacent is the line that's next to both angles, touches both angles. So we have to think about which letters are important here. Now, H is important, we have a value for it, and O is important, we have a value for that. What we don't have is a value for the A. So we write down a little acronym here. So CAR-TOA. We'll look at which one has got O and H in it, and it's actually SO has got O and H. The other two, I've got one of them, but not both. So we draw the formula triangle for SOA. Now, again, you don't need to remember how to construct the formula triangle because it's the same order as the word, S-O-H. And remember, if we do maths with letters next to each other, it's multiply. If they're on top of each other, it's divide. So now we think, what are we actually looking for here? We're looking for the missing angle, A. So we're looking for the angle that's always related to the trigonometry word. In this case, it's sine. So we cover that up and we look at what we've got left over. And we've got O over H. So now we can write out our formula. The sine of our missing angle A is equal to O divided by H, and we can substitute. O is 135.2 and H is 180. So we can work that out. 135.2 divided by 180 will give you 0.751 recurring. And again, that's a very odd number for an angle. It's a very, very small number. So you're going to think it's not actually the angle we're looking for. We're looking for angle A, but we found sine A. So now we have to solve the equation. We have to do the inverse of sine to both sides. That gives us A is equal to the inverse sine, so press shift and then sine, type in your number, and you should get 48.69 degrees to 2 decimal places. So now let's have a look at one last example. So we have the adjacent. This is the line that's next to the labelled angle and the right angle. We've got hypotenuse, longest side, which is opposite the right angle. And we've got the opposite, which is opposite the other labelled angle. Think about which ones are important. Now, A is important because we have a value for it, 106.2. O is important because we're looking for it. It is labelled. It's labelled A. We don't know the value, but it is labelled. This is what we've been looking for in this question. H isn't labelled, doesn't have a value, so we're not interested in H. So we write out SOHCAHTOA, and we look at which one of these has got both of these letters. We've got an A and an O, and they're only in TOA. The other two only have one of each, not both. So we draw the formula triangle for TOA. And again, you don't need to remember how to do it, because it's just in the same order as the word T-O-A. Then remember, when you're doing your maths, if they're next to each other, it's to multiply. If they're on top of each other, it's to divide. So now we've got to think, well, how are we going to do this? Well, what do we have? We actually have the angle 48.4. So that'll be representing the tan. The trigonometry word's always about the angle. And we've got the adjacent 106.2. What we don't have is the opposite. So we're going to cover up the opposite because we don't have that. So what do we have? We've got T and A, and they're going to be multiplied together. So now we can write out a formula. We can write that O, or rather we'll write O first. So O is equal to tan of the angle multiplied by the adjacent. So now we can substitute. So the opposite is labelled A. Tan of the angle is going to be tan of 48.4 degrees. Be multiplied by the adjacent, which was 106.2 centimetres. So we can type that into our calculator. Press tan and press 48.4, and it should get 1.126 and some more decimal places. Then multiply it by 106.2, and what we get is 119.6 to 1 decimal place. And for a final answer, you can say that's also going to be in centimetres. So write the units if you don't have them. Degrees for an angle, and then whatever measurement it is for lengths. You'll notice for this one, we didn't need to rearrange. So actually finding missing sides is probably a little bit easier than finding missing angles. Moving on to the medium questions, you'll notice with the easy questions that both Pythagoras Theorem and SOHCAHTOA, they only work with right-angled triangles, and all the previous examples used right-angled triangles. Now we're going to look at triangles which aren't right-angled triangles. Now, we have a few methods to work these out. So the first method is called the Sine Rule, and the Sine Rule is as follows. A over sine A is the same as b over sine b, which is the same as c over sine c. So what does this mean? Well, first we need to talk about the labels. Now, a, b, and c can be any sides of the triangle. It doesn't matter which sides they are, so we could just say a, b, and c. And it doesn't really matter which ones are which. What does matter, though, is then the relationship between the angles and the sides, because we've got the lowercase a and b and c, and the uppercase a, b, and c. Now, the lowercase versions of a, b, and c are these sides. The uppercase are the angles. So we've got a uppercase c on the angle that was already labelled for us. And you'll notice it's opposite. I've drawn it opposite side C. The same has to be true with A and B. Angle A is the angle that is opposite side A. No part of side A touches angle A. And so the angle that's not labelled is angle B, with the uppercase B, because it's opposite side B. So you have to label the triangle first. That's really important. Now, once you've labelled the triangle, we can start to think about how we're going to substitute this in. So let's substitute all of them. So A was 111.8, and it's over the sine of capital A, which is 38.4 degrees. Then we look at B. Now, we don't have sine B, and we don't have angle B. So actually, B is completely useless for us, and you'll find this with Sine Rule. It'll be one of these parts of the formula that you don't need to use. You'll notice that all three parts are equal to each other. So that's substituting for C. Now, we don't know what the angle capital C is, so it's still right sine C. If we know side C, it's 177.8. And so this is the formula that we've got. We've got some information for A and capital A, and we've got some information for C and capital C. We have a full set of information for A, and we have a partial set of information for C, with one of them labelled as a thing we are looking for in the question. So again, what does the formula mean? Well, it means that the ratio between the side and the opposite angle is consistent. So the ratio between A and sine A is the same ratio as between C and sine C. So now we can work out the equation. So we have 118 divided by sine 38.4. If we type that into your calculator, we get 179.989. So it seems like that's actually pretty close to 180. So that's going to be 180 to 2 decimal places. On the other side, we've got the 177.8 over sine C. So to rearrange this, what we need to do is multiply both sides by sine C. So 180 sine C is equal to 177.8, and then we can divide both sides by 180 to get something for sine C. Now this is going to be a little bit awkward, so I'm going to show you another trick you can do with this. So rather than carry on with this method, when we're looking at ratios, it actually doesn't matter which way around you divide. So there is an alternate version of the formula, and the alternate version is you just switch numerators and denominators. So sine A over A will give us a different ratio, but it will still match up with the ratios of the other sides. So let's try the substitution this way and see if it helps us. And again, we're looking at A and we're looking at C. So sine A is going to be our sine of 38.4 divided by side A, which is 111.8. And that's equal to sine C, which we don't know yet. We don't know C. We know the lowercase c for the side is 177.8. So it looks just like what we've just done and abandoned, but the fractions are the other way around. So sine 38.4 divided by 111.8 gives us, now I'm getting quite an awkward number here, it's 5.56 times 10 to the negative 3. But we don't need to use that number because we just keep it on our calculator screen. And that's going to be equal to sine C over 177.8. But our next step will be to multiply both sides by 177.8. So what might be helpful here is to do the rearranging before we actually work out the values. So if we multiply both sides by 177.8, we're going to multiply that by the sine 38.4 over 111.8, and using the brackets, that's going to get us something for sine C straight away. And what it gives us is 0.9878. Now I'm going to have my final answer to maybe 2 decimal places, so let's write our working out to 4 decimal places. Now this is sine C is equal to, and we want C on its own. So now if you think about our rearranging equation skills, we want to do the inverse of sine to both sides. to get C on its own. So press Shift and Sine to get the inverse sine, and that should get you 81.05 degrees to 2 decimal places. One extra important thing to point out with Sine Rule is that you can have 2 answers to some questions. So for example, this one, 81 degrees as an answer, but you can also have 99 degrees as an answer. So be aware there's 2 possible answers, but this is something we'll look at in future videos when we look at trigonometry on graphs. We will show visually where the 2 answers come from. Moving on to the next example. Again, remember that Sine Rule, you can have A over sine A, B over sine B, and C over sine C. And the ratio of each, again, by dividing them, is going to be the same. And you can also do the same ratio the other way around. You have sine A over A, sine B over B, and sine C over C. And what we saw with the previous question is that one of these arrangements is going to be easier. And what we saw is it's actually easier if the denominator is a number that we know. If the denominator is a missing number, then we start to get, a little bit more complicated. So always do substitution with the aim of having a complete set of denominators. So looking at this question, let's label it. So we've got side C already. So angle C is going to be the angle opposite. Now, the way around A and B doesn't matter. So let's just randomly call them A and B. But then angle A has to be opposite side A, and angle B has to be opposite side B. Now you'll notice here we've got 2 angles and 1 length, and we want a complete set of denominators for easier rearrangement later on. So for this question, we actually want to use the top arrangement with the signs on the bottom for the denominators, because we've got 2 angles, so we're going to get a full set of angles for the denominator. In the previous question, we had 2 sides, so then the bottom arrangement where the sides are on the denominator made more sense. So let's substitute. So we don't have anything for A, so we're not going to substitute into A. For B, B itself is 135.1, and then sine B is 57.6. Again, just make sure you don't get the lowercase and uppercase b's mixed up. Lowercase is a side, uppercase is an angle. Then we have C. So we don't have the length of C, the side, but we have C, the angle. It's 78.2. And again, we chose the arrangement like this because now we can get numbers for both of our denominators. Now, before we substitute, we can do the rearrangement first. So what we want to do is multiply both sides by sine 78.2. So we'll do that first. That'll give us sine of 78.2 multiplied by 135.1 divided by sine 57.6, and that'll be directly equal to C, so we don't need to do any rearrangement after that like we did with the previous question. So you're looking for a side, you'll get your answer straight away. If you're looking for an angle, you'll have to do inverse sine to get it. So into my calculator, I'm typing sine 58.2, then I'm typing multiply. What you might want to do is just put the 78.2 in brackets, so just make sure that entire thing is set to be applied to sine. So when you multiply, you're not multiplying the angle, you're multiplying the entire sine. Open a bracket, 135.1, and then divide it by sine. Again, open a bracket for what's inside the sine. 57.6, close the bracket for the sine, and then close the bracket for the entire thing. Altogether, that should give you 156.6 to 1 decimal place, and it'll be centimeters. Again, the more difficult thing here is getting everything to the calculator all at once. The important thing is put the angles in brackets and be careful with a double bracket. Make sure you close both brackets. So let's have a look at another sine rule question. Again, the first job is to write down the formula, and it's not a particularly difficult one to remember. So you're basically dividing each angle by the opposite side. Remember, the formula can be written either way around. So don't worry about getting the numerators and denominators the right way around. You need to be thinking about it both ways around anyway. So the important thing now is to label our triangle. Look at any existing labeling. So we've got angle B is what we're looking for in this question. So side B is the side opposite. Then we don't have any other labels. So let's just call what we've got left angle A and side A, because they're opposite each other. So that means the bit that's not labelled will be angle C and side C. When we substitute, the aim is make the denominators be numbers, not algebra, because then there'll be way more rearranging later on if you've got algebra in your denominator. So which version are we going to use? Well, we've got 2 sides, A and B, with values. So we want to use the top version. The denominator is going to be A, B, and C. So let's substitute. So sine A is sine 102, and A is 176.1. That's equal to sine B. Now, we don't know what B is yet, we're looking for it, but it's over B, which is 114. Now, we think about when we rearrange this, we're going to be multiplying both sides by 114. So that's going to give us 114 multiplied by sine 102 over 176.1, which will be equal to sine B. So doing your rearranging first is a good idea. So let's type that into the calculator. 114 multiplied by, open brackets, type in sine, and with 102, put 102 in brackets. A lot of calculators like you doing that. Then divide by 176.1, and then close the bracket. That's going to give 0.6332 to 4 decimal places, and that's sine B. Now, we don't want sine B, we want just B on its own. So we have to do the inverse of sine to both sides to get rid of that sine. Press shift and sine on a calculator, do that of the answer, and we're going to get that B is equal to 39.3 to 1 decimal place. As always, these questions at the end, just think, does my answer make sense? Does it fit in to what the other numbers that I've got? So I've got 102 and I've got a 39. If those numbers add up to more than 180, you would know that you've made a mistake. Also, a very small or very large number, you know you made a mistake. If you've got 0.6 as your answer, that's very, very small for an answer to a question, and it probably means you've not done your final step. If you get a very, very large answer, something more than 180, then again, that's an impossible triangle, and so you know a mistake's been made. Moving on to the next question. Now, we can label the sides the same way. So side C is already labelled. That means that angle C is opposite it. And the other sides are going to be A and B, and the other angles are going to be capital A and capital B. Now, there's something different about this question, and it's when you substitute this into the sine rule. So what you're going to get is, you're going to get sine C, which is 101.3 over C, is equal to, so let's look at B, so we have sine B over B, which is, we have a value for that, it's 117.8, equal to sine A, which we also don't know, over the length of A, which is 83.1. Now, the problem with the substitution is we don't have a complete set of values for either A, B, or C. And we need a complete set of values to kind of eliminate one of the variables almost. So now we have 3 variables in the question. So we actually can answer this using the sine rule. So we're going to use something called the cosine rule instead. So again, cosine rule is something you can use when we don't have a right-angled triangle. And it's actually kind of a modified version of Pythagoras Theorem, where we have an adjustment built into the formula because we don't have a right-angled triangle. So cosine rule is c squared is equal to a squared plus b squared. So at the moment, we've got Pythagoras Theorem. But again, it's not a right-angled triangle. It's not a 90 degree. It's 101.3 degrees. So we have to make an adjustment. And the adjustment is take away 2 lots of AB multiplied by the cos of C. So the angle that you're cosing is the one that's opposite the actual side you're looking for. So let's substitute. We're looking for c squared. A squared is 83.1 squared plus 117.8 squared. Then we're taking away 2 lots of a times b. So again, a is 83.1 and b is 117.8. Then multiply that by cos of c, the angle, which is 101.3. Now, you can try and type all of that into your calculator all at once. I probably suggest put brackets in the multiplication section. Just make sure your calculator actually is doing the multiplications first. It's using BidMass. Then it should be okay with this. So let's try typing it in. 83.1 squared plus 117.8 squared. Take away, so I'll put some brackets. 2 times 83.1 times 117.8 times cos. Open some brackets for the angle. Type in 101.3, close the brackets for the angle, and then close the brackets for the multiplication section in brackets. When you press equals, I'm getting that c squared is equal to 24,618.754 to 4 decimal places. Now, of course, that's c squared. So just like Pythagoras Theorem, we need to square root both sides. That will give us c on its own. Now, if we square root that number, we're going to get 156.9 to 1 decimal place. And it's a side length, so it'll be in centimetres for this question. So this is all about, firstly, knowing which formula to use. If it's a right angle triangle, you'll be using Pythagoras Theorem for sides, or SOHCAHTOA for a mixture of sides and angles. If it's not a right angle, then you'll be using the sine rule or the cosine rule. Using the sine rule, if you've got kind of a set of A, B, or C that matches up, you'll be using the cosine rule if you don't, and you've got one variable each from A, B, and C. Let's have a look at one more cosine rule question. Start off with a formula. C squared is equal to A squared plus B squared. Now, again, that's Pythagoras Theorem. It's not a right angle triangle. We need to make an adjustment. So we're taking away 2 lots of A times B times the cosine of C. Now, when we label this triangle, you'll notice the angle has already been labelled A for us. So the thing we're looking for is not C, it's actually A. We can label this as normal. So we've got side A, which is opposite angle A. Then the other two are going to be B and C. The order's not going to matter. Now, what we can do is we actually have alternate versions of the formula we can use if you want A equals, or rather you want kind of A in the formula. Because A squared is equal to B squared plus C squared minus 2 lots of BC multiplied by the cos of A. So have a look at the changes that I've made here. Mainly, I've just swapped the positions of A and C, and that's fine. You can even change the labelling of the question if that's something that helps you, if it's already been labelled for you. The key things to know is that the letter that's equal to is also the letter in the bracket. So if it's C equals, we've got a C in the bracket. If it's A equals, it's an A in the bracket. Although, of course, it's lowercase and uppercase because one's the side and one's the angle. Then the main bit of the formula is either going to be A and B in 2 sections or B and C in 2 sections. You can even do this with B equals with a similar method. So let's do our substitution. So we've got A squared, 169.6 squared is equal to B squared, 160.6 squared, plus C squared, which is 186.2 squared. Again, that's Pythagoras Theorem, but we need to make an adjustment. It's not a right angle triangle. So we've got 2 lots of B times C. Then the numbers we just substituted. And then we're multiplying that by the cos of the angle we're given, the cos of A. And we don't know what that is. So there's going to be some rearranging of this soon to actually find that out. So we want the term with A in it on its own. So I'm going to take the left-hand side, I'm going to take away the kind of Pythagoras Theorem part of this away to get it over to the other side. That'll leave us equal to the multiplication section. So now we have only one term to deal with on the right-hand side with the A. Then, to get the cos A on its own, we can divide by all the things it's multiplied by. It's useful to do this because if we actually squared out these numbers, we have some quite long numbers to write down lots and lots of times. Just keeping them in this format makes it easier to do the final calculation. So we divide by the negative 2 times 160.6 times 186.2, but we're going to keep the cos A on that side. So now we can try and type this into our calculator, and it can be a good idea. You put into calculator, put brackets are in the numerator and brackets are in the denominator, just so it's really clear to calculator which numbers are being divided by which. So I'm opening our brackets. I'm going to type in 169.6 squared, take away 160.6 squared, take away 186.2 squared, and then I'm going to close our brackets. Then I'm going to divide it by, open some brackets for the denominator, negative 2 times 160.6 times 186.2, close those brackets, and I'm going to get an answer. And what I'm getting is that 0.53 is equal to cos A. Now, as usual, we don't want cos A, we want just A on its own. So we need to do the inverse of cos to both sides to get A on its own. So that's going to be cos to the minus 1. So press the inverse cos button on your calculator, type in your answer, and what we should get is that A is equal to, and I'm getting actually to 1 decimal place, it's 58 degrees. If you ask for 1 decimal place, write 58.0 though. Moving on to the hard questions, we've got another triangle that isn't a right angle triangle. What we're going to try and do here is find the area of this triangle. Now, normally the formula for the area is base times height. However, that only works for a right angled triangle. Now, if a triangle that isn't right angled, what you need to use is that the area is equal to half A multiplied by B multiplied by the sine of C. And the labelling scheme works the same way as the labelling scheme for the sine and cos rules. So what we need to do is think, well, it's sine C, the sine of an angle. So we'll call the angle C. That means that the opposite side of this is going to be length C. The other two are going to be A and B, and again, that could be in either order. And already we've got what we need to substitute into the formula. So firstly, we have a half. We're going to multiply it by A, which is 183, multiply it by B, which is 173, and then multiply it by the sine of C, that being 54 degrees. And so there, if we actually do this multiplication, we're going to get our answer. So type in half times 183 times 173 times sine of 54. And that should get you, for the area, 12,806.3 to 1 decimal place. Then we need units. All our measurements are in centimetres. So this will be centimetres squared for an area. Now, if you look more carefully at the formula, again, the kind of normal form of the triangle is going to be base times height, and then you want to halve it for a triangle. Now, we can see that we actually have half base times height in our formula. We have a half times 2 of the lengths. Again, because those lengths are not perpendicular to each other, there isn't a right angle between those two, the base and the height, then we have to adjust it. So we have to kind of multiply by the sine of C to make that adjustment. So just like with the cosine rule, it's a formula you already know with a bit extra to make an adjustment for it not being a right angle triangle. Moving on to our next question. And again, I'm going to find the area of the triangle. So the area is equal to half multiplied by A, multiplied by B, multiplied by the sine of C. You'll notice in the formula we have each letter represented once. So we have the angle C. The opposite side is going to be C, but we're not using that as part of the formula. And you'll see in this question we don't have a value for it. Then A and B are going to be the two other sides in either order. And again, like the previous ones, we'll have capital A, the angle opposite little a. We'll have capital B, the angle opposite the little b. But again, we're not using those extra angles. So now we can substitute into this. The area equal to a half times A, 128, times B, 101, times the sine of C, which is 88 degrees. So again, we can type that into a calculator. So type in a half or 0.5 if you prefer, multiplied by 128, multiplied by 101, multiplied by the sine of 88. They'll give you your answer straight away. And we have 6,460.1 to 1 decimal place. Then units, the measurements are in centimetres, so an area will be centimetres squared. Moving on to our next question. Again, the first job is to label everything that you've got. So we've got the angle, we're going to label C. Opposite that is side C. Side B is already labelled. We're going to be looking for that in this question. So the other side must be side A. We can substitute into the formula. And for this one, it's a kind of reverse question because we have an answer for the area. It's 11,891.3, and that's equal to a half times A, which is 236.4, times B, which we don't know yet, we're looking for it, times the sine of C. That's the sine of 41. Now, again, a good tip here is maybe do your rearrangement before you actually work out these numbers. So what we could do here is think, well, we want B on its own, so we need to divide by all these multiplications on the same side as B. So it's actually going to be the area divided by the half times 236.4 times B. We're going to leave that on the right-hand side, so times sine of 41. This is going to be equal to B. Now, if you don't want to do this and you want to work it out in smaller steps, that's actually absolutely fine. But this could just save you a little bit of work, as then you're not trying to, do half times 236.4 and then, maybe divide that over to the side and then do the sine 41 next and then do that separately. This just makes it a lot simpler to do everything all at once. So on your calculator, type in 11,891.3. Press the divide symbol. Now, when you have multiple things for your denominator, it's a good idea to perhaps put brackets around it, just to make sure your calculator reads it all together. So open some brackets. Then we have 0.5 times 236.4 times sine of 41. You might want to put the 41 in separate brackets. Then make sure you close the brackets for the denominator. And I'm getting for B altogether 153.3 to 1 decimal place. And it was a length, and our lengths are measured in centimetres for this question. For the next question, C has already been labelled, which means that capital C is on the opposite side. But we don't actually have an angle for that. And so we can't really use the formula I've written out here. Now we label the rest of it. We can label the other sides A and B, which means that our angle is going to be a capital A if we label it this way around. Then capital B is the other angle that's not labelled. Now, what you can do with this formula is the kind of letters used to label it are kind of up to you. So you can also always write the formula out in a different way. So you say the area could be half of, and you could have B and C. sine A. So all we're doing is, again, we're just using two sides and an angle. The angle has nothing to do with the other two sides. It's not the angle it's opposite to. It's the angle it's next to. And so don't be afraid to either label the diagram differently. So perhaps that lowercase c I should label an A and just done it a different way with different letters. We've got the same answer. Or you can rearrange the formula. And it's very much how you can change the formula for the cosine rule. As long as it's two different sides and a different angle, you're going to get the same answer. So now we can substitute. The area is equal to 4,876.2. Then we've got a half multiplied by A, for the new formula, multiplied by B, which is 95.8, multiplied by C, which is the thing we're looking for. It's labelled with a C at the start. That's indicating that we're looking for it. And then the sine of A being 58 degrees. And again, it can be easy to think, well, all these multiplications, we can get C in its own by dividing them all to the other side. So as you can solve an equation skills, divide by all those extra bits. And we're going to get a half times 95.8 times sine 58 as the denominator on the other side. And it's all equal to C. So we can type that into our calculator. Again, a good idea to make sure the denominator is in brackets. Shouldn't make a difference on most calculators. Type it all in. Again, you might want brackets around your angle. Make sure you close all the brackets you open. And I'm getting my final answer, C is equal to 120.021 decimal place. And again, this is in centimeters for a length. So now for the last question, we're finding the angle. Now the angle's labeled C, so we use a standard version of the formula. Opposite to that, the lowercase c, the other two sides being A and B. So let's substitute. So the area is 729.2, and that's equal to a half times A, which is 32.7, times B, which is 44.6, multiplied by the sine of C, which we don't know yet. Now again, we've got all these things multiplied together. We could multiply them and get a value, or we could just rearrange this to have them dividing on the other side. So if we divide both sides by the entire set of multiplications, then it's going to look like this. That means we can put it into the calculator all at once. We don't have to do multiple steps writing down, intermediate answers. So if you type that into your calculator, 729 divided by, open some brackets, a half times 32.7 times 44.6, close the brackets, and we get that sine C is equal to 0.9997 to 4 decimal places. Now that's sine C, and we just want C on its own. So we need to do inverse sine to both sides here to get C on its own. Press shifted sine, type in your answer, and I'm getting 88.6 degrees to 1 decimal place. So that's the missing angle.
Ouch! This is why in some videos I have explained scratches.